visualization matrix. Problem number 3 has been selected for 6 in the project. This is the plan schedule for the project. Let me think about WLR first. WLR stands for Retrolocating Radar, which is also called as SWATI. It's a mobile radar system designed for automatic fast location of artillery weapons. The main types of weapons against which SWATI is designed are mortars, guns, and rocket launchers. So WLR has got two vehicle configuration. One is radar vehicle and power source vehicle. Radar vehicle on the left and power source vehicle on the right. And it can be operated remotely with the help of a remote display located clear meter from the system. And this is a pictorial depiction of working of WLR system. You can see when electronic beam from antenna is transmitted and when it detects the shell of the target, it extrapolates the projectile motion of the shell of the target to identify where exactly this shell of the target is fired. So coming to business case, Bharat Electronics has received order for 12 members of WLR systems in the year 2023 of worth rupees 840 crores. So delivery date was 24 months. So initially, 2 members were planned to deliver in the year 23-24 and rest 10 members were planned to deliver in the financial year 24-25. So as per the voice of the customer, WLR should give us state-of-the-art radar for better detection and tracking, and we should have radar viewing system with zero functional issues. It should have improved accuracy for detecting target. It should be operator friendly. It should have better accessibility, and it should have better maintainability. So this is a configuration of radar vehicle. It has got majorly 4 subsystems: radar shutter, antenna assembly, and vehicle mounted rotating platform assembly. And this is the major area of concern on which this case study is based upon. Coming to the problem statement, vehicle rotating platform assembly consists of following part. It is also called as a swing system. It is critical for antenna and shelter location. So initially this assembly was outsourced to Mysore. However, out of 7 systems delivered, 6 systems had functional issues after the system integration. So this rejection due to these functional issues had to be addressed from log priority. So 6 sigma methodology was used to solve this issue. So this is a customer complaint received regarding functional issues in swing system. To further understand the issue, cycle diagram has been drawn with the supply being DME subcontracted vendor, and the process of this assembly consists of placement of bracing on the bottom structure, assembling the gearboxes, then placing on the common platform, placing common platform on the vehicle, and then inspection, then the final output being assembled vehicle mounted rotating platform. So to further CTQ has been drawn with the customer need being operational WLR system, which has a prerequisite of operational rotating platform assembly, and the key drivers are inspection, assembly, process, and the material used for listing and wear, and CTQ parameters are shown. Further, CTQ specification table has been drawn, where CTQ specs for each and every CTQ parameter has been identified, and different definitions have been defined, and control status has been listed. Coming to the measure phase, this is the step-by-step process of assembly of rotating platform assembly. Coming to detailed explanation of the problem. So generally, this input to the input for the rotation of platform is given to the local control panel. This is the local control panel. Here you can see the input given is plus 135 degree as you know. So as per the given input, the platform has to rotate clockwise 135 degree as shown in the figure left. However, due to functional issues in the system, it is unable to achieve the desired aspect. So this is the data collected for initial 7 systems. So based on that, the detection opportunity table has been drawn with the opportunity being vehicle rotating platform assembly. And the Z value has been calculated and it was found 0.43. Coming to the analysis phase, each and every step has been analyzed. And cause and effect diagram has been drawn where primary causes have been identified, and for each primary cause, secondary causes have been mapped, and for each secondary cause, tertiary causes have been mapped. And validation of causes has been done to find whether it's a valid cause or a non-valid cause, or it's a significant factor that is contributing to the valid cause. By through finding of the causes, we have arrived to 3 root causes. One is improper measuring of gain and TMT, and inaccurate measurement of high point, technique of high point and gain, where SOP without clear images at critical stages. So I have introduced the point high point and gear. Basically, what is high point? So on while manufacturing the gear, due to unavoidable errors, the gear lead profile will not be exactly concentric. Generally, the gear measures at the pitch circle of the gear. So since it is not concentric, so each and every teeth will have a different point of contact when it measures with the other gear. So high point is basically when this teeth will have a highest point of contact. So this is the CNX diagram. So each and every root cause has been analyzed. Here you can see that is a main gearbox with the racing gear. So this gearbox has got two dependent gears which are meshed with the racing gear. So during meshing we have to ensure that the gap between these two gears are 1.5 mm, which is a design specification, and which is a very precise job and requires a lot of expertise. And after meshing the gear, before meshing the gear, we have to make these gears independent with the help of the spline and mesh the gear and make these gears again dependent. And inaccurate, actually this vehicle rotating platform assembly consists of three major gearboxes: main gearbox assembly, manual gearbox assembly, and feedback gearbox assembly. And all three gearboxes have to be assembled at the high point to ensure that there is smooth rotation in the gear. So measuring of this high point is a very critical factor, and also any error in this measurement would result in the gear locking or slipping, what we have observed in the systems that the engineer is built. And coming to SOP, though there was SOP there, but we found out that assembly personnel were finding it difficult to comprehend the SOP because of lack of images at critical stages. So each and every root cause has been addressed. We have for improper meshing of gear and TNT, we have developed in-house skill by preparing a detailed step-by-step procedure, and we have provided comprehensive operating training to operators, and in the presence of DNT team, operators were made to assemble the system. Coming to inaccurate measurement technique of high point gear, we have standardized the procedure and provided the training to the operators in the presence of DNT, and we have monitored the process continuously to track high point measurement data to identify the trends and potential issues. This is a picture showing the high point measurement with the help of our dial gauge on the racing gear. Coming to wake SOP, we have done the gap analysis, then interviewed the quality staff, testing staff, assembly operators to know exactly where their pain points are, where they are finding the difficulties, and we have identified missing steps, unclear coding. Then we have developed a standardized procedure. This is the video showing the functioning of sewing system after the improvement. So this is a WLR system. Here input is given through local control panel, the assembly panel. So input given was 135 degrees clockwise. So this entire platform is rotating 135 degrees. And this is the antenna from where the beam gets transmitted. These are the reports. So to understand whether this improvement is statistically significant or not, we have carried out two proportion tests. Since p value is less than 0.05, this improvement is statistically significant. Coming to control phase, this was approved SOP signed by the project manager and handed over to us. So this is the new SOP. The critical images that we can get this name. So this is the inspection clearance given by the customer after the improvement. Coming to tangible benefits, we have calculated how much cost we have saved, and this is the document approved by our ID. So in terms of yield, before it was 14%, after the improvement there was no defect at all, so it was 100%. And lead time reduced from 50 days to 5 days. And so 11 members of radar systems were dispatched, which generated revenue of 7.4 crore. And in terms of monetary value, total savings were 13.2 lakh. Coming to intangible benefits, we have utilized resources effectively. There was no wastage of resources, extra manpower for rework, and wastage of material also got reduced. We have developed in-house expertise, customer satisfaction was achieved, and we have delivered all the 11 systems on time. So this is the actual achievement schedule. So the experience gained by Indian radar SBU has also been utilized by missile systems radar, which has got a which has got a similar kind of DRSB for the missile guidance radar project, which was exported to Armenia in the year 2025. So this is the appreciation letter given by the assembly medium of missile systems SBU for getting utilizing our expertise. So all in all, BEL received supply orders for 12 members in the financial year in the year 2023. So initially 2 members were planned to deliver in the financial year 23-24 and then it was in financial year 24-25. Initially this assembly was outsourced to them also. Later due to functional issues, we have developed in-house expertise and we have done in-house. And the contribution for the SBU is 640 crore, which is approximately half of the total ROD. And expertise gained in this radar system has also been utilized horizontal radar and utilized by missile system radar SBU for the export project. And this radar played a crucial role during operations in detecting the from where targets from where these agents are right from and utilizing those targets. And we, in fact, we have received appreciation from MOD also for the wonderful functioning of this radar. So these are the tools used.